everyone, and welcome back to the Information Bottleneck. And today we are going to talk with Jean-Francois. He's a director and distinguished engineer at NVIDIA. Hi, Jean. Thank
Hello.
you for joining us.
Thank you, Ravid, for inviting me.
And hey, Ellen. Thank you for joining us too.
Hi, Ravid, and hi, JFP, and I'm really excited to chat with you about Kaggle because sometimes I forget that place exists and quietly makes some of the most skilled AI engineers stand out.
So today we are going to talk a lot about Kaggle competitions and also about agents and how to use agents and how NVIDIA thinking about how to use agents. But maybe we can start with the recent announcements from NVIDIA this morning. Can you say a few words about like how NVIDIA and how you think personally about agents?
Yeah, okay. So this morning, Jensen, our CEO, made a number of announcements at Computex, Taiwan. So I won't cover everything. He made some announcements on hardware, like chips for laptops. But I'm not on the hardware side. I'm on software at NVIDIA. So closer to me, there are two main announcements. One is a new larger version of our Nemotron model, Nemotron Ultra, which is comparable to top open source from China mostly. But the main difference is it runs much faster. Seconds per second output is way higher because this model has a hybrid architecture where some parts of a classical transformer were replaced by state space model like Mamba. So that's one, and the other it's optimized for 4-bit quantization, which is something NVIDIA is pushing both in software and hardware. So we'll see how people consume this model, but you get similar performance like Qwen, DeepSeek kind of models, Kimi, but much faster. So we'll see. Then a little caveat, you have numbers and benchmarks and you have reality. So we are looking for feedback from reality, but on benchmark, it looks very competitive. Then closer to what I'm doing, NVIDIA also announced an agent skill repo with skills for NVIDIA software. So agent skills, well, let me say, agents, coding agents like Codex, Cloud Code, Cursor, and open source like open code, they are great. You can do a lot. I'm using them all the time. But they may not know very well some NVIDIA libraries. They are trained on what you have on GitHub, for instance, and maybe there are not a lot of examples, especially for new libraries. So you need to help agents, and you help them with documentation tailored to them, but there is a specific type of documentation called agent skills, where you document how to perform a workflow, how to accomplish a task. Skill is just a prompt in Markdown format that you would give to an agent if the agent needs to perform a given task. So in a skill, you describe the task name, what the task is, and then the prompt to follow. And this has emerged as a standard. I started with Cloud Code, and now it's a standard supported by major agents, and not only coding, but also OpenClaw or Hermes agents. And at NVIDIA, we wondered how to expose our libraries using agent skills so that generic coding agents or generic agents can use our libraries effectively. So we just shipped on NVIDIA, on GitHub, NVIDIA skills, number of skills. And our angle, so creating skills is easy. Creating useful skills is a bit more tricky. And I've tried a lot of skills. I was even the first at NVIDIA to speak about skills, and I've tried a number of them. And surprisingly, a lot of them are not helping. the frontier models in these coding agents, the Codex, but there are others, they work well. So improving, I'm not saying they are perfect, not at all, but they work well. So improving them, you must show you improve. So I've driven an activity to define an evaluation standard for NVIDIA and a way to test. So basically, you define a set of tasks you want your agent to perform, and then you compare how the agent performed the task with and without the skill. So it's quite simple, but just doing this consistently, reporting on the result, making these tests, we now have at NVIDIA a pipeline where people can just submit skills, them tried with Codex, Cloud Code, Cursor, and others, and have a report out of it, and maybe recommendations on how to improve the skill. So we've automated evaluation. And the one that passed the bar, the first ones, were just announced. And there will be more. And this has triggered interest from third party like OpenClaw and Hermes and the big frontier labs, so that they will redistribute our skills as well. And that's something we have done recently. Again, the goal is to help agents not trained on NVIDIA software to use NVIDIA software.
And how much, like, at the end, how many skills you think there will be that related directly to NVIDIA? Do you think like it's hundreds of skills?
Yeah, more than 100, yes. It's increasing every day, so I don't have the count now, but I've seen a counter 121. So I don't know how many are published yet, but the pipeline is hundreds.
Do you have any opinions on the value of, so for example, there's different implementations of skills, like Claude Code's skills are prompts, as you've mentioned, but Codex, I've seen at least one skill that supported executing like deterministic specified code. And I think MCP servers are often what people imagine skills to be, in a sense, in that they connect people up to data that enables their models to do better. So do you think that these like data connectors can have more value than the skills, or what's your opinion on that?
First, there is no difference between skills using Codex or Cloud Code. You can use one with the other. It's the same standard. But the skill is a skill.md file, which is markdown, a name, description. You can have a bit more in the header, in the front matter, like license and whatever. And then you have instruction, a prompt in markdown. And the skill can refer to code, to MCP tools, to whatever. Or a CLI that the agent should call. The point is, if you have a MCP tool and you want it to be used in an agent, you need to give a description. And the description is loaded whether the agent needs a tool or not. So the problem with MCP tools is it eats your context very quickly. Agent skills have something called progressive disclosure. So in theory, it doesn't work perfectly, but in theory, when you have a set of skills, the agent will only read the front matter, the name and the description, which is a small part. And if the agent decides it needs the skill, it will read the rest. So you would put the long, then you can create a skill for each MCP tool. You just have the front matter describing quickly the relevance, and then you have the detailed instructions on what the MCP tool does and examples, etc. And this way, you don't eat your context, is loaded on demand. That was the first selling argument of skills. People were reporting that moving from MCP tools to skills, they were reducing their context consumption by 100 times. So that's huge. So now if you want an agent to use a CLI or a data connector, you can encapsulate with an MCP tool, but you can also just document how to call the CLI in a skill. But the agent will just say, okay, if I need to use a CLI for, I don't know, Kaggle, for instance, I can use this skill, but I know there is a skill about Kaggle CLI. And then whenever the agent needs to actually connect to Kaggle, it will read the CLI description in the skill, and it's loaded only on demand. And one way to think of skills is to have a modular prompt. You load the part of the prompt you need when you need it. So that's theory in practice, and that's why we need to test. So among the default metric we use is the skill loaded when it should be, and is the skill not loaded when it should not. Both are issues so we measure both. So we have a set to test a skill. As I said, we have a number of tasks. The test set must include tasks that do not need the skill, so that we check that the skill is not loaded when it shouldn't be.
And do you think like in the future, like it will be like every company or like, I don't know, like some setting that I want to adopt, like I will have like just new skills, or do you think like the solution will be to, I don't know, fine tuning or like doing something more permanent?
That's maybe. So let me give an answer. Maybe that's not exactly your question, but now if you have an agentic system and you want it to learn or evolve, you can update the model, say via reinforcement learning. You can evolve the prompts. So there are some method like JPA or DSPY, not used a lot. Maybe they're underused. And the agent itself, or you can just add more skills to your agent. And that's something the latter is just, you add more skills, so you just add files, and the agent just use the additional info automatically. So we won a benchmark called DabStep, which is a data science benchmark. And we won it we had a data science agent. We made it solve each training task in the benchmark. And for each of the tasks, the agent looked at how it solved the task, then created a skill out of it. So it accumulates agent skills. So for each task, you have a skill describing the workflow used to solve that task. So it's just taking the agent trajectory, and that could have been too long, and for the trajectories that succeed. So maybe there were more than one try. But for the success one, then distill the trajectory into a skill. So a prompt that tells the agent, do this, and this, and you solve the task. And then, so if you have 100 tasks, you have 100 skills, which is too many. And then a second phase, we had the agent look at the skills and generate a smaller number of more generic skills. And then at the end, we use these more generic skills with the agent to work on the test data. We submitted this for the test, and we won the benchmark that way. So it's a new way of learning. The agent accumulates procedural knowledge in Markdown files. So we don't change the agent architecture. We don't fine tune the models. We just add more context for the agent, for the prompts in the agent. And this is quite effective. I believe it's a new form of learning. We're not the only one having this idea independently. News Research, for instance, who develop Hermes agent, they build their agent on this as well. Their agent continuously creates skills as it goes, and they were lacking the compression part that we had. So they've added it a month or so ago. As
you don't
accumulate, you need some time to distill them into a smaller set of more generic ones. Yes.
But you don't afraid from kind of like overfitting, because like at the end, if like when you see more, like when you create more skills, and like even if you compress them, right, like still you can say, okay, like the model at the end will say, okay, so like for these very specific types of problems, I will decide this, and like for these very specific types of problems, I'll decide that.
Maybe it's so. First, I'm glad you're asking about overfitting, because I love it when people discuss overfitting. It's a great topic. That may be true. So so the compression is really, the goal is to make skills as generic as possible, but could still overfit. But now, if you think, there are two flavors of long-running agents. One is you have one task, like find a new molecule or solve a math problem, and it's fine if it runs 2 weeks on a single task. And then there are long-running agents, especially personal agents, that runs repeatedly similar tasks. Say you have an agent that, I don't know, digests your email and Slack and social media and blah, blah. If it generates, and then you tell it when it did a good job or not, and then it generates skills to overfit to what you believe is a good way. Overfitting is fine. It overfits to you, and that's okay. So overfitting may be fine if you never use it outside the training data distribution, right? So it can be good in that respect. But yes, you're right. That's why your question about overfitting, let me return it. I believe most LLM benchmarks do not check for overfitting. Overfitting is rewarded.
What do you mean?
Say you take a benchmark. Test data is public. So you can say, let's take MMLU. I'm not saying it's a bad benchmark, just an example. Say you fine-tune a model on mass task, you run it on MMLU, you have a score. If you use this score to guide you on your checkpoint selection, you overfit. I don't think so. I've even seen people publishing papers to improve score across a set of benchmarks automatically. That's overfitting by definition.
Do you think it's a problem?
Yeah, it's a problem, and that's why people continuously report that in real usage, performance is not as good. It's always so.
But like people will claim, right, that like currently with like in the LLM area, right, that even though like most of the benchmarks have like public testing set, still if you improve on these things, like everything will go up.
I'm not saying I agree. So
Okay.
the benchmarks are good to rank the models, but they are not good to estimate the actual performance on actual problems not seen before.
Well,
What I'm saying is there is a drop between the benchmark values with public test data and actual use performance. But what you say is if a model is better on benchmark than another model, it will be better in practice. This is probably true, but it does not change the fact that both overfit to the public bunch, to the public test. And a great example, so I'm sidetracking, but I want to say it before I forget. Last year, we worked on SWE-bench quite a lot, SWE-bench verified. And our team at NVIDIA won the benchmark at a point on top. We stopped working on it because we tried O3 at the time. And we found that O3 was, so our agent, so SWE-bench, it's about solving GitHub issues. So you're given a repo, a tag. So you check out a repo, you have an open issue on it, and you need to produce the edits in the repo that fix the issue. The problem is that these edits are in a commit in the public repo as well. LLMs are trained on it. So we found that, so our agent was first trying to identify which files in the repo to edit and then do the edit straightforward. We found that O3 was picking the right files to edit without looking at the file content. Yeah. So what's the meaning of the benchmark after this? So my position is the only reliable benchmarks are benchmarks where the test data is not public. So it has to be managed by something. And if you want to evaluate, you train on the training data, and when you're ready, you send your checkpoint, your LLM or whatever is tested to whatever runs the benchmark. But this is really a minority.
But even here, like you have the problem that like even if you don't have direct access to the test data, you still get like some signal, right? So you can optimize over the signal.
One shot, you don't loop. You can't loop. I agree. If you can loop and use the score, it defeats the purpose. But the difference is, so you have to choose what you submit before you know the score and not after. That's the difference. And that's how Kaggle competitions are built. in Kaggle, you know the score after you've selected the 2 submissions you make for the final scoring, and that's why it's valuable. It's not the only place, but I think it's a good model for benchmarks.
So I just had some questions about Kaggle, and also in relation to evals. First of all, Kaggle is something that long predates the, post 2022 ChatGPT generative era, and continues to be a really big deal for kind of figuring out who actually is good at least training classifiers and other optimizable kind of verifiable rewards, in machine learning. So I guess my question is, how has that shift to language models really shaped Kaggle in the last 3 or 4 years? And then also just a quick side question around, you two have been talking about how you validate models. I mean, back in the era before ChatGPT, back when people used Stack Overflow, there was a slightly lesser well-known cross-validated being the name of it, machine learning variant of Stack Overflow. And cross-validation, that technique, was something that was really drilled into my head in machine learning classes.
Yeah, and so let me start with this.
I will.
Story.
Before you answer, I would just maybe we didn't say it, like you're a grandmaster at Kaggle, like many times, and like you had like a long history on Kaggle, and like you're running a team that actually like has like again expertise in Kaggle competitions. So yeah, now you can answer.
That's why we're asking this stuff.
Before joining NVIDIA, I was asked, I did a PhD in machine learning a long time ago, then moved to something else, mathematical optimization, and we got acquired by IBM, and someone noticed I have a PhD in machine learning, which is irrelevant now. It was very different at the time. But say, help us on machine learning, and I say, where can I find current machine learning practice? And I found Kaggle. And I say, guys, I have a PhD, you will see what you will see. Third, and I didn't do well in my first competition, so I said, oh, okay, to learn. And I became good at it, as you say. There is a ranking of the greatest of all time on Kaggle, and I've been third on it. So I've been active, and that's how I entered NVIDIA, actually, thanks to what I do on Kaggle. And yes, to your point, Alan, one thing I did at the time as well was to take Andrew Ng training on machine learning. And he made it clear that overfitting was the evil trap for machine learning. And cross-validation is the main weapon for it. So I've integrated this. I did bad in my first Kaggle competition because I overfit. And that's the only time. I have a reputation to not overfit on Kaggle. I'm very conservative. And this was, that was a difference between a good data scientist and a bad one. It's not the good ones don't overfit. And to your question with ChatGPT and now Gen AI and agents, all this knowledge is disappearing. People just let agent do their job. And I'm seeing it on Kaggle, back to your question, how is Kaggle impacted by Gen AI? Kaggle compute is limited. You cannot use frontier models. The cost would be too. So they cut internet access, one for the cost, second to not leak the test data. So you cannot use frontier models when you submit on Kaggle. You can only use small open source, let's say 4 billion or 8 billion maybe. So you don't use elaborate Gen AI inside the submission, but you use it outside to prepare for your submission. And there people use agents, they use Codex, they use Cloud Code, they use whatever. They use frontier model to run agents continuously or to generate synthetic data. So there is a lot of opportunity for pre-training, whatever you submit to Kaggle. So the shift is in automating the work of the data scientist, basically. But So there are a number of competitions where all top teams claim to use AI agents. I predict there will be a bloodbath because they overfit, but who knows? Because these agents, they have no notion of overfitting, or they are told to improve the score, they improve the score, period. So we'll see what happens. One is ending in 2 days. I'm looking for it.
Which one?
Berkeley. So it's a competition I did every other year. It's like the 5th edition, and I won gold medals in every of them. And I know the main issue is not to overfit, so we had to be very conservative. I doubt all the vibe coders or vibe data scientists understand how much overfitting is easier now with agents.
So what do you think? Like, what do you think actually make a good data scientist? Like for Kaggle competition. Now, what are the types of problems and solutions that you are trying to solve, and how?
So I believe what makes a good data scientist is 2 things. The first and foremost is to be able to evaluate the performance of a model accurately, say via cross-validation. Because you need to select your model or pipeline before you know the score. So you need to be able to evaluate your model correctly so that you pick the right. So during a competition, you train a number of variants, and you have to pick 2 that are scored on a hidden test set by Kaggle. If you don't pick the 2 right, your 2 best, well, you don't do as well. And usually competitions after completion, the forum is full of people who say, "Look, I had this variant that would have won the competition if I had picked it." Okay, but you didn't pick it, so you missed the point. So evaluating properly. That's a key thing. The second one, but this is changing, to do well, you need to experiment in a scientific manner. You have an idea, you must think about how to evaluate if it works or not, and then you perform the experience with and without the idea. And depending on the result, you conclude that the idea is useful or not. So it's like any experimental science. So you have to do it rigorously and efficiently so that you perform. The more experiments you do, the better in the end. But you need to evaluate properly. And I see people, for instance, they modify 5 things at a time. And then if the result is not good, what do you conclude? Maybe you had 2 good ideas out of the 5 and 3 that were bad. So just change 1 thing an experiment gives you 1 bit of information. It's better or not. So you should only test 1 thing at a time in an experiment. You cannot test several changes. And this may sound obvious, but I still see it all the time when I team with people. They create a new variant. They don't even run cross-validation. They submit. It's not as good. Okay, but you change 2 things. What do you conclude? That both are bad? No, you can't know. So if I summarize, evaluate properly, and then perform experiments as fast as possible. Where agents are changing the game is you can use them to automate experimentation a lot. So I have people on my team, they run Codex or Cloud Code continuously, and it runs experiments in parallel at a large scale. And this can be really large scale, like running experiment on Slurm clusters for you and continuously. So it's leveling a bit the field. It changes a lot. And as a result, my team is a top consumer of tokens inside NVIDIA.
Do you have leaderboards?
Well, if you use Codex, enterprise plan, you can have you have a leaderboard of users for your organization. And the top 3 are from my team.
Wow. Actually, related to that question, There's also the AutoML revolution that I think was happening right before ChatGPT and LLMs got really good. And there were projects that I'm sure you're familiar with, such as AutoGluon, which I
Yeah.
think comes out of AWS, AutoTeapot, and etc. Many of them feel like they're on life support, and even whole startups like God dang, like a whole AutoML startups I feel like kind of died during that time. What's your opinion on
Because,
that?
yeah, continue. So
H2O, that's what I was thinking. Sorry.
automating experiments with the coding agents is killing this. We get better results. Yeah, I agree.
So, but okay, but do you think like the future is like coding agents that are doing this like hyper power to sweep and like running experiments on the clusters, and you just like set the right metric with the right validation? What about like creativity of ideas, for example? Do you think agents are
So,
there yet, or?
first, I still have my doubt about overfitting. So we'll know soon because there are number 3-4 Kaggle competitions where people just rely on coding agents. So we'll see. If, as I believe, overfitting is an issue, then that's an area where the human controlling the agent should work on. But that's so training a classifier or regression model or pipeline is well understood. So I wouldn't be surprised if this gets automated quickly. But then, where you need creativity is for more complex domains. I don't know, drug design or general agents navigating an unknown environment. So I believe the frontier, I believe LLM and agents will digest repetitive tasks. It's automation. But creativity, they are not at the level of human creativity. How can I say it? So I'm using Codex lately most of the time. And my view is people say, oh, you should treat this as a junior intern. No, because it can do things that a junior intern can't do. It can do a lot very well. But it can be wrong by large proportion as well. So it's a mix of a genius and a dumb person. It's extreme. When it works, it's awesome. And when and sometimes it makes mistake no human would do. It lacks common sense. It lacks the limits are it does not have a global model of what the code does. So it has a local view, very accurate, but I keep arguing with my coding agent. So I ask, okay, update and do this and this and this. Yeah, but there is this assumption, so we must test for it. I say no, because in this other part, we live in a state where the assumption is true. Yes, you're right. So it lacks a system-wide understanding. And when I see people who let coding agent run for hours or overnight, I think that what they code is simple. My experience is when you have something complex, designing new algorithms or with system-wide dependencies, it's complex. It's beyond what they do. For instance, an experiment colleagues did, they created automatically in 2 months an equivalent of PyTorch. So the fact that this could be done is impressive. There was an NVIDIA blog recently, like 2 months ago on it. So a fully autonomous multi-agent system created an equivalent of PyTorch, which was functionally correct. That's impressive. But it's 10 times slower than PyTorch. And it's because there is no system-wide optimization or locally the code is great, but
So, but do you think this is something that will be solvable in the future, or do you think
hard
they
to.
could keep?
Everybody who said, "Oh no, they would never do this or that," proved wrong so far. So I'd be cautious. What I'm saying is the current limit I see to coding agents is they lack a global context. So that's where humans still have a role. So I still believe humans are in the driving seat. But it's like mechanization, in the past, peasants, they were using their muscles to work with the ground and the soil and do stuff. And now they have machines and they are driving the machines. It's the same for agents. It's automation. But the machines, they work both better and not as good as people say. When they work well, the agents do really, it's impressive, the code they can write quickly, but you have to check because sometimes the code is just wrong. And I don't understand how people can trust it blindly. They shouldn't.
So the work that you're doing right now with these code agents, you know, and talking about many of these different harnesses, I'm aware of like Nemoclaw, and my understanding was that NVIDIA, some of what Nemoclaw is trying to do on top of OpenClaw is improve the sandboxing for enterprises. I want to hear your opinion on sandboxing in general for models.
That's another issue indeed. So we see horror stories. There was one a month ago where a company, I think it's Rightways, they lost all their code or all their, I don't know, because the agent erased some database. So my take is there should be always a human in the loop. I don't believe full automation is okay, except if it's you make it solve a task and it iterates till the task. But you look at the end result. So as long as it iterates, it's fine. If it goes wrong, too bad for you, but that's it. But consuming the output of an agent without looking is wrong in my view. But people do it anyway. So you say, okay, should we sandbox? Should be? So NVIDIA answer to this is called OpenShell. And we announced OpenShell for OpenClaw, I believe, this morning, and maybe Hermes agent, I believe both. So it's a way to sandbox. So sandboxing is controlling, mostly about controlling actions and outbound communication, but it's not perfect. And then Nemoclaw is an installer that install OpenShell with your favorite agent. But the sandbox is called Hermes. So my view is that we're just starting a long journey about securing agents. What I believe is it's extremely, so coding agents are good at automating software engineering, but they are good at automating hacking as well. And recently in France, a hacker was like a 15-year-old was arrested, and the guy in 6 months hacked a number of sites and became famous in hacking community, and not just in France. And when he was arrested, he said he did not write a single line of code. He used coding agents to do all the hacking.
That was way before Mythos.
So, what do you think about Mythos? Do you have any opinion about it? About like the, you know, to release it to the public versus not?
A model, but I dislike anthropic communication, not just on this, but on the rest. In the past,
best PR machine.
No, it's a bad one. Years ago, OpenAI was a bad PR. They were announcing semi-conscious models and AGI next quarter, blah, blah, blah. They've stopped. And now Anthropic is fear-mongering all the time. I will eliminate 10% of jobs in the next 6 months, or 90%, I don't know, it depends on the day. Because it's too dangerous to be shared. We must forbid Chinese models because they will be used to hack, blah, blah. So they try to kill open source. If Mythos is so great, they should open source and let everybody their vulnerabilities themselves. You know, if all they want is to benefit humanity, that's what they would do. But of course, that's not what they want. They want to create fear so that people queue to use Mythos, presented as the only way to avoid, say, if you don't use Mythos, someone else using Mythos will kill you. We know this kind of argument. So the good news is OpenAI is reporting similar performance, at least on public benchmark, and it will take a few months before open source achieve similar performance. So they have a small time window. They try to monetize by telling people how great Mythos is and how dangerous it is if you don't use it. So I believe it's a good model for what they. So technically, I think it's a big progress. But
what do you think like are the missing parts for open source models? You know, like
I don't think there is a
why?
missing part there. Lots of reports show they trail frontier closed source by 6 months or 4 months, or it depends on the report. They don't miss a lot. They are coming. So what
But
the model achieves at a point, you can bet that within a year you can do the same with open source.
But do you think it's like what? Like that NVIDIA doesn't put like enough like compute, enough people, like they don't
Ah, you
like
say
adequate
why is
data?
NVIDIA not a frontier model? So first, in some areas, we are the frontier, like speech to text. NVIDIA is really among the best. Now same for image and video generation. So we demonstrated what we call world model to generate actual videos that can be used to train autonomous vehicles. So that's a big activity at NVIDIA, and probably Tesla has something great there as well, but well, frontier. And now it's general text generation. We're not frontier, we're not OpenAI or Anthropic or even Google. But it was decided last year to accelerate on open source, and that's the Nemotron Ultra announced this morning that shows it. So it's competitive with the best Chinese open source, and NVIDIA will continue pushing. So expect better models from NVIDIA. Open source models. Maybe they will always be a bit behind frontier models, but not so far. So what do people need? Sorry. I believe something, and it happened in a previous life when I was in mathematical optimization. If you have the best team in the world on a topic, the best people not on the team wants to join you. No, but and I believe so. Being top in a field attracts the top people. And I think that works for Anthropic and OpenAI these days. It's a dream of most, not all probably, but most people working on LLMs would love to join one of these because you're part of the best. So I think NVIDIA focus on training frontier model was not known much, and well, not yet at the top. So, but we are hiring great people all the time now. I can tell you, not just for this, but for agents and reinforcement learning. And another area where we are the front is for robot, so real-world physical models for robots. We have Groot, and I'm not a specialist, but it looks like one of the strongest model available. And at the same time, we don't. So the goal of NVIDIA is not to replace Anthropic or OpenAI. They are, especially OpenAI, one of the best customers. So it's more for people who can't afford the top to give a good fallback via open source. And there is also another reason why people can't use frontier model necessarily. It's when you apply it to confidential data.
So like how do you see like the future? Do you think like we'll still have like, I don't know, 2 or 3 frontier models that are closed source and different open source that like if now you have some confidential data, like you want one model that will run locally or to fine tune on your own data, or like something different, I don't know, very like specific models for specific domains, or like maybe agents that using different models at the same time.
I think one evolution I'm seeing is what people call world models. So far, we have models that are good at interacting with software. But if you ever want to have a robot that, might, I didn't know, but it's a classical definition of it. Yeah, I will personally be convinced that we have an artificial intelligence, literally, is when I can ask a robot to make me coffee in a place it does not know. Looking for coffee machine, for beans, if not, go to a shop, buy coffee, or, all sorts of things that are not rocket science at all, but that you would do naturally as a human. You're asked to do a task and you will find a way autonomously to solve it. There is nothing in current AI research that is ensuring progress on that front. So I believe we will have systems that can perform specific tasks as well or better than humans in many places. And this is not new. I mean, we know AI, not the same flavor as now, but AI is better than people at chess, at Go, at games, as I said before, I worked on mass optimization. It can solve planification problems better than anyone, etc. So this will happen, but having a truly autonomous general purpose system, this
take
is
time.
It's not a focus. But I see more and more people starting labs to work on something a bit like this. So more autonomous and more general purpose. Yanloka, for instance, is one, but not only. There are US labs as well being created, moving beyond what LLMs and agents using LLM can do. I have no clue how far they can go and how fast they will go, but it's starting. Regarding LLM agents, I believe this is going to automate a lot of white-collar tasks, which does not mean replace people. It means that people will have AI work for them and they will focus on something else.
And do you think, like, at the end, the solution for like end-to-end, like real world problems will be different than Kaggle competitions? Do you think, like, fundamentally we need different solutions for these problems, so we can transfer and like we can learn on one very like specific setting and then to transfer these solutions to another setting?
So in Kaggle, you have two current competitions that are about agents acting in a complex dynamic environment. So one is Orbit Wars, the other is ARC-AGI 3. So these are steps you want to develop autonomous agents that can make a decision real time in a dynamic environment. But if you look at, so this is going in the direction beyond what LLM can do. But if you look, these environments are extremely simplistic compared to the real world. So it's really, as I said, it's really the starting of a long journey. I don't know if Kaggle will be the relevant place. I believe to move forward, you need more elaborate simulations than the ones in these competitions. And for instance, if you look at DeepMind, they started in making agents for games like so AlphaStar, I don't remember, it was Dota maybe, so a complex multiplayer game. The environment was more complex than in these competitions. Maybe the way to get to the kind of autonomous AI I define as AGI, you need to work in video games, or I don't know, which are more and more realistic to experiment. Because in video games, you don't need to have the physical robot, so it's easier. But even if you have AI that autonomous and learn in this environment, then you will have to put them in a robot, and that's another level of complexity. So the journey towards autonomous robots is long. The Terminator is not going to happen anytime soon.
I'm fascinated that you brought up Dota. I'm the gamer. I think Ravid plays a lot of games too, like retro gaming, but I'm definitely the one who's currently the gaming addict out of the two of us. And I'm always fascinated. Do you think that the relative weakness that LLMs or AI agents have in playing certain games, things like Dota, and also like NetHack, which is also well studied and famously difficult of a game. Do you think it just goes back to like the context window and agent planning and agent communication, or do you think that there's kind of other factors, or even like maybe an architectural problem where we need like some rethinking outside of like the
Yeah,
LLM paradigm?
of course, I believe it's not seen as a major challenge. So you don't have people spending billions on it, on solving it. People are spending billions in adapting what seems to work for math coding to other domains. Remains to be seen if they will succeed. But my take is we need something quite different to do well in dynamic environment with multiple real-time decision making. But I may be wrong. I don't know if LLMs can produce tokens in the millions per second in few years. Who knows? Who knows? I have no idea. My gut feeling is we need something different. But the story has shown that so far transformers are eating the world, and we can't say they are done, so we'll see.
And so we're almost out of time, but I have like one more question. Like, what do you think about this claim that like at the end AI is kind of a bubble, and like the only company that actually makes money out of it is NVIDIA?
What I believe is some people make too bold claims. As I said, OpenAI was, but they stopped. Now it's Anthropic. So this can create expectations and then people are disappointed. So there is a risk. I'm old enough to have seen an AI winter, and it happened for the same reason. People are just making too bold. And there was an AI winter even before I was born. 1960, Herbert Simon and Alan Newell made predictions in 1960 that in 10 years, AI will be the world chess champion. It happened, but it happened like 30 years later, not 10. Anthropic, so Dario Amodei prediction that AI will replace 90% of white collar jobs. This is really not helping. So that's for the bubble part. Then the bubble, no, I think what we will see is as a token cost decreases, and it's decreasing every few months, it will drive adoption more. If you look at people who started using Cloud Code and now Codex and others, they're hooked. Going back is difficult. Same for ChatGPT. People who started using ChatGPT or alternatives now, going back to not using them, it's difficult. So I don't think it's a bubble. Then there were arguments about circular economy, blah blah. If you look at the level of investment and the money in the other way, it's not circular. And not just for NVIDIA. Google invests in Anthropic or Amazon, and they sell chips. Nobody says it's circular. So I don't think there is a bubble. I don't understand. As Jensen said, the way NVIDIA stock price evolves and is due to the fear of a bubble, probably. He doesn't understand. Nobody understands that. I must say, what are people afraid of? It's not clear. So we'll see. I don't believe it's a bubble. I believe some people make too bold claims. So if people trust these claims, then yes, it's a bubble. But, this is not just in AI. I mean, there is a company claiming they will establish humans on Mars not too far in the future. You see a kind of claims as well that we may not see anytime. So people make bold claims. I don't know why. Probably for funding.
Okay. We didn't talk about ARC price. Maybe briefly.
Okay, so
What like you had like you competed in this competition? Maybe tell us in a few words about it.
Okay, so ARC-AGI is a set of challenges created by François Chollet, the inventor of Keras. He was at Google DeepMind for a while. Now he has a company. So ARC-AGI 1 and 2 were about solving puzzles. So you have tasks, and for tasks, you were given some example of puzzle. So a puzzle is you have an input, a little grid, and then you have an output, and there's a transformation like you color all the interior of points in yellow. So that's a transformation. So you had to build a system that learns from very few examples how to move from input to output. So it's about few shot learning, really, in a little visual environment. And last year, when the competition started, LLMs were solving like 1 or 2% of the task.
Up to
1 or 2%, yes. And we won with a 4 billion model on Kaggle Compute, meaning at a cost of 20 cents per task. We solved 27% of the task. This was the best score available. Since then, the frontier models have made progress, but so far, nobody beats us on a Pareto frontier. So nobody does better than us at the same cost. So it was a huge achievement because what was incredible is before the last day, we were third. And we jumped to first place and increased our score by almost 2x the last day at the last hour in a 7-month competition.
how?
Yeah. And how did we do it? So to solve this with a 4 billion model, it's impossible. So we actually distilled frontier models and frontier open source like GPT-OSS 120 at the time. So we looked at the puzzles. We use LLMs to generate additional puzzles. So we used code generation and the capacities of frontier model reasoning to create a set of 1 million puzzles. And then we trained our small model on it. So we distilled frontier models on this benchmark. And there is a new iteration of the competition, and we are leading it. We are nearly at 50% now, still at 20 cents, which is huge compared to what frontier models. To get 50% with frontier model, you have to spend dollars per task instead of what we do now. And then there is an ARC-AGI 3 where it's not static. It's like small video games you have to solve. So it's not Dota, but it's moving into, you have opponents. This one is very challenging, and the best score on Kaggle is like 1% now. So it's really challenging.
So, and what do you think about like the ARC-AGI 3? Do you think this is something that it's solvable? Do you think it's something like
It's very hard. We are entering it, so we'll see in a few months. It's a several months competition. If you are not limited by Kaggle and you can use frontier models, people publish multi-agent system that solve up to 40% of the task, so it's doable, but at a very large cost. So the question is, can we have a small system do something? It's open. These are well aligned with what I say, exploring the limits of what you can do with LLMs. So these are good. This is way past regression and classification. It's really, so I hope for Kaggle they will have more competition like this. Time will tell, but these are relevant.
Okay. I think we're out of time. Do you have anything else that you want to add?
No. It's
To advertise.
For people who watch this, none of this was prepared. I didn't know about the question, so I hope it's interesting and entertaining. But and I would, if people want to see really what SOTA is in practice, just enter Kaggle competitions. To me, it's a legal drug. Kaggle is a legal drug. So it's legal to do it, but it can be time consuming, but it's worth it. It's worth it.
I agree. Okay. Thank you so much for joining us. It was a real pleasure.
Thank you.
And thank you for all the audience. Thank you so much.
Thank you, everyone.